FP3 2012. I'm going to do the first part from first principles just as a reminder. So if y equals the inverse cos of 2x, then cos y equals 2x. Differentiate the left, we get minus sine y dy dx. Differentiate the right, we get 2. So dy dx equals 2 over minus sine y. Cos squared plus sine squared is 1. So sine squared is 1 minus cos squared. So sine squared is 1 minus 2x all squared, so that's 1 minus 4x squared. So if we take this and substitute it in, dy dx equals minus 2 over the square root of 1 minus 4x squared. So our original function was f of x equals the cos of 2x plus the inverse cos of minus 2x. When we differentiate the first, we get minus 2 over the square root of 1 minus 4x squared. And whenever we differentiate the second, we're going to get 2 over the square root of 1 minus 4x squared. Denominators are the same, so we can just add the numerators. 2 take away 2 is going to give us 0. So next part of the question, we're asked, what does this mean? Well, it means between our limits, f of x is constant. To evaluate f of x, then, that means we can put in any value. I tend to always put in 0 anytime I'm working anything out. So that gives us pi over 2 plus pi over 2, which is pi. Okay, I'm going to start by changing tanh to sinh over cos. And we know that sine squared plus cos squared equals 1. Whenever dealing with the hyperbolic, we know that if we have a product of the signs, then we change the sign. So this gives me that cos squared is 1 plus sinh squared. So cos would be the square root of 1 plus sinh squared. So this gives us sinh, which is tan t, all over the square root of 1 plus sinh squared, which is tan squared t. So that is tan t over the square root of sec squared t. So that's tan t over sec t. And tan is sine over cos, and sec is 1 over cos. So cos's will cancel, and that leaves us with tanh equals sine t.